Good morning. So today on behalf of the team from Heat Lab New Zealand, I would like to proudly present to you our work that we have done about the developing of the new headset, which is called Multi-channel Dynamic Immersion. So the device allows the user to see the real world from two different optical channels. And by simply pressing the button, the user can switching between seeing the real world and virtual world very easily. My name is Kien, and here's our team from Heat Lab New Zealand. So as we know, virtual reality or VR has been supporting user with many applications and to accomplish different tasks in our real life. And one of the goals for the virtual reality technology is to support the user to be immersed and to be focused on the work in the virtual environment. However, in reality, the situation is more complex, and especially when the user have to stay in front of the desk with multiple objects. So they will not be able to fully disconnect from the real world. They need somehow to have certain degree of connection with the object around. For instance, you do the coding in the virtual environment, and you need to somehow, certain point in time, keep working and also quit checking the keyboard to find a special key or something. It's also happened in the case that you need to quickly check the phone when it's ringing for the caller, or to check who is the caller, or do the texting to your friends. Maybe you want to keep checking the work and also quick take note in the real world, or just simply find the watermark. So while you are wearing the headset, you can do so by simply flipping it up or take off the headset. However, these actions moving back and forth between the real world and virtual world, causing the certain moves, and it could result in the fact that you break the immersion or focus. So have an interactive plane on top of the two screens. So the user will use the eye gaze to point to this area to enable the technology to be able to see the real world. So they point to this press button, they will be able to see the real world. Depends on the integrated technology for the devices. And we also have the pink screen behind the table. This one only appears after the user finishes 3 sentences. And the text in the screen will tell them which task in the real world they need to do. And from that moment, they will know that they have to pause their virtual experience and start using the interactive plane to see the real world to accomplish the task. For the experiment, we designed our experiment based on the within subject approach, where the user has a chance to experience all 4 devices. And we managed to have 60 participants, aging around 24 years old, and half male and half females. We define our independent variables as the 4 devices, and we have also dependent variables for both subjective and objective measurement. So the green one is objective measurement for the performance of the user, and we also use the standardized questionnaires for measuring subjective measurement from user, and also one customized questionnaire to ask about the preference from the user. So this is a very short demo of what you are going to expect to see from within the MDI HMD. So you can see the main view, we have physical space of the experiment, and the one on the left is what you can see from within the headset when you look through the lens. And the one on the right is the instant of a LCD will capture by a camera. So we have 4 LCD panels, but it's only one captured from here. So if you are not seeing, if you are staying in the virtual environment, what you see is just virtual world with tables, screens, and the planes. So if you want to see the real world, you just simply press button. There will be a camera plane appears on the virtual environment, and also the LCD panels on the left. On the right here will be open for you to see the real world. So if you want to focus on using the video see-through experience, you look closer and you can easily identify the objects, and it's very easy to do the task from within the virtual environment. And if you want to focus on seeing the real world using the LCD panels, you can see it from the image, which is enlarged with very clear details of the object around. So that is a very short demo of the what you're going to see from within the MDI device. So in terms of the result, unfortunately, we couldn't find any significant difference in terms of objective measurement for the performance and the standardized questionnaires for the subjective measurement. But however, we found that it's very interesting that when we ask user which device is the easier to use when they have chance to experience all the four devices. Interesting that the user tend to select the MDI device, which as the easiest to use device compared to the baseline. So there's a fact that MDI is a very complicated device where it has two technology integrated, while the baseline has no technology, just bare HMD. So in terms of the conclusion, we find that the users tend to select the MDI or HMD as the easiest device to use. Maybe there's we ask also the comments from the user when they finish their experiment session, and we can sum up some advantages of this device where the MDI with the VST may support the user to better do note-taking, and the fish island helps them to search for the objects on the table quicker, and the DI technology in the MDI headset support them to do the using the smartphone easier when they do the texting and calling. And in terms of future work, we will apply what we learned from an experiment to improve the design of our HMD and create more optimal experiment, and maybe expand our research space to the haptic and audio cues. Thank you. That is for my presentation. And if you want, you can come to chat with me. And I also bring my headset here. So if you want, you can give it a try. And I will be in the red colors uniform around. So thank you. Yeah. So this one is like, I don't remember, maybe it's like 60 or 70 as a time my professor bought it. So, and the fish island is you can buy it in any shop. The Arduino is around $30, I think. And the LCD panels, we just recycle the broken 3D shutter glasses, active 3D shutter glasses. So it's cheap, and also we have 3D printing part to mount the fish islands. Yeah, I haven't estimated the codes in more details, but yeah, it's around.